We'll start then. I need this one. Not.
Jalas, we have Ganesh in the call.
Come again, please.
Ganesh is there in the call.
Not now. Any issues, Nikhil?
I was trying to reach him many times since so many days, but I'm not able to. He's not picking.
Okay.
Yeah, I'll call him. No problem.
I'm just going to read my file. And today we are going to continue with the PySpark syntaxes, and we are going to see a bit of joins and group by operations. Okay. Here I need to and this one. Okay, so I have actually read my same country's file again, and I am going to convert that into uh, a data frame. I have actually also shared the notes and the files in the chat box. You guys can refer that. If I do a show here, just to verify the results. Okay, so we are all good to start. Okay. So for today, I have two things with me. That is, one is like group by and join we are going to discuss, and then we are going to discuss the sort operations with the data frames of PySpark, and then tomorrow I'm going to cover that some use cases and some kind of a day-to-day work of a data engineer, like some context, like as Josh and Nikhil, you guys were missing the context here in this complete course. So I'll try my best again tomorrow to set up that part. But yeah, before that, we are not going to stop this PySpark syntax in between, and then we are going to finish this today. So see, I have actually read my this country's file, and I have used the same schema as mentioned above. Now I am going to read one more file, and that is a region data frame file. Okay, so I am going to upload one of my S3 file. And here I'm going to create a folder, region. In this region folder, oh sorry, my bad. In this region folder, I need to upload a file that I have here. Okay, and see, again I'm repeating, this is the URI that we need to take to modify the address in your notebook. So I have an address. Obviously you guys cannot create the same bucket. Your bucket name will be different, folder name can be same. Okay, for that you need to copy this SEURI and just paste it here and replace the file path. That's all we have to do here. Okay, I'm going to read this file. For that I need to define my schema. Okay, and let's check what we have in the regions data frame. Okay, so here we actually only have two columns, okay, with us, that is ID of region ID, and then we have a name. Okay, so these two things only we have in our file. So now, like we do some joins in SQL, the same thing we can do here also. But before that, actually, okay, I'm just going to perform join first. So let's say I want to join my two files exactly like I perform joins in my SQLs, or if you guys understand SQLs, like left joins, right joins, inner join, cross join. Okay, these are a few examples of join. And I hope everyone here knows the joins in SQL. If someone does not know join, then please let me know. Okay, so if you see here, in my first statement, I'm performing a inner join. I have read two files. Okay, one is my countries data set, second is my region file, and with this I'm actually going to apply some joins. In this, to define join syntax, we have to use something like this, where we take our data frame name, okay, on which we want to apply some join. Then we say dot join to join the data frames. Then on which table, like which data frame I want to join. So like the first data frame is actually treated as the left table. Okay, then second the data frame is treated as a right table. Okay, then I have to provide the condition here. Condition, I'm saying that countries data frames region ID should be equal to region data frames ID column. Okay, if I open both these data sets for you for easy reference, this is my countries data set. Okay, here I have one region ID, that is my column I. Here I have region ID 30, 20, 50, like that, and then I have my region file. Here I have simply my ID, and then I have my name of the region. So let's say I want to join based on this ID, and I want to get the name of the region. So to achieve this task, I have performed a join, again repeating the table or data frame which is outside of the join syntax is actually your treated as your left data f. It is actually treated as your left table of a SQL. Then data frame inside the join statement is treated as right table of your SQL. Then we need to provide the condition. Okay, then we need to provide the condition, and in condition I am saying refer to region ID of my country's data frame. refer to ID column of my regions data frame. Okay, and then after comma I have to say the join type. I hope that you guys understand the join types. If don't, then let me know. I will explain you that also. But here in this case I am applying a inner join. Okay, this means all the IDs should match to get the rows in the output. That means only the matching ID I will get in my final output. So if I execute this statement, it worked, and then I'm going to do a show here. And if I open my notepad plus, you can see now I should have my name. This name I'm getting from my uh, regions data frame. This ID and this name I'm getting from my regions data frame. The two data frames have now completely joined, and I have all the columns from both the data frames. This is my inner join example, and if you have any doubt about this or any questions about this, you can please let me know. Okay, then same way I can actually go ahead and apply a left join. I'm going to get my join data frame, and it just output is going to be similar as the right join only in this case, because it's completely matching. Okay, we can see it's completely same, because here right join, left join, and inner join, it's not going to make a difference, because all the IDs, all the region IDs are present in both the files. That's why they are going to be uh, joined perfectly. So yes, if you have any questions about these joins, and then I have right join also. So these are the three main joins that we have in SQL. Those you can actually also apply here in. And if I just say joined df dot show, let's check out its results. Okay, before I take a pause again. So right now we are seeing, if you see this output, we are seeing that all the columns are appearing, and you know like this. If you just see this thing, I have this region ID from my left table also, and I have the same ID called as ID from my right table also. And sometimes we have some requirement where we do not want the complete columns after joins. We might want to restrict the number of columns that we are getting in the output. So to achieve that, we can have a select here. Okay, so if I just do it like this, I say join, like the same join conditions that I'm doing, that I have done earlier. Then after that I am simply saying select the name of country. Okay, from the country's data frame, just select the name, then alias it as a country name, then select regions data frame, and from this I need the name of the region and alias this as a region name, and third column I am selecting as a population, and I am going to sort my data frame based on population in the descending order. So this is equivalent of SQL query where I select, where I say select name as country name, regions tf dot name as region name, population from countries tf, then from countries tf, right inner join on uh, region id equals to id, order by population descending. This is my equivalent SQL query. If you are a SQL developers, this is your SQL query is going to be. So if I execute this thing, I do not have all the columns. I'm just selecting and getting the only the required columns after a join operation. This is what I'm getting as an output here. And if you see the syntax slide more closely, so whenever in PySpark you want to break your code in multiple lines, as you can see, I have applied joint here, and then I'm saying select on the next line. We have to say a backward slash here we have to use, and that means code is going to be away, code is continued on the next line also. So if I remove this slash, then my syntax is going to fail. It's going to say invalid syntax at line 1. So I have to apply this slash also. So any questions, any doubts about this? Okay. See, silence means that you are getting whatever I'm trying to say, you are all getting it. Then we have group by operations. So let's say in SQL we also have this group by operations where we group our data based on some columns, and then we perform aggregated operations on that column. Those aggregated operations are such as getting the average of that column, or getting the max of that column. Those kind of operations we do on the numerical columns. So same we can achieve here also. For that, I have to say simply, I will take my data frame. Okay, I will take my data frame and then I will say group by. Remember, PySpark is a case sensitive language, so it has to be written in this format only. If you make a G capital or if you make B small or anything else you try to do, it's going to fail. So I am saying on my country's data frame, apply group by on column region ID and give me sum of population. Like what is the sum of the population per region ID? I want that detail with me. So what my code is going to do, it's going to take all the region IDs. Okay, so we do have region IDs here, multiple region IDs. So for all the region IDs where my region ID is 10, it's going to take the rows and it's going to add up the population column. Okay, this is what we are doing in this code. So if I execute this and I say dot show to verify the results, this is what I'm going to get. I'm getting every region ID and then the population in exponential numbers. I'm getting that. Basically, I'm getting the sum of the population here. And let's say I want to group by on region ID and I want to get a minimum population for that particular group. This means in this data set, let's say I group by on region ID 10. Okay, so whichever is the minimum population, so that I can see 30, and this is for a country called South Georgia. Okay, so I am going to get this detail, like 30 is the number that I should get. If there's something else in this data set which is less than 30 also for this particular group, then I'm going to get that thing. So if I apply this code, you can see I am getting every region ID and its minimal population. So for region ID 10, actually I do have some row where it is 0 also. That's why I not got 30. Then let's say I want to do an average on the population. So same way I can achieve average also. So it's basically it's the same syntax, is just a different function after group by I'm applying. So you just have to say that on data frame group by, and you have to provide the column name or column names. Like you can also use the multiple column names inside this in a list format, and then you can do a one more function to do sum, minimum, average, sum, max, or anything that you can do on the aggregated operations. So I'm going to say group by on region ID and getting the average of population. So you can see I'm getting the average of the population. So see, this kind of operations are very much, or you can say very frequently used in the real-time projects. You have to sometimes do some mathematical calculations on your numerical columns, more majorly in the fact tables. And for that, we have to apply these functions such as maximum, minimum, average, sum, and those things actually comes very much handy. And if I want to do sum of two columns, you can do it like this. So it just that I am saying do a group by on the same region ID, but this time I want to get some of the population also and some of my area kilometer square also. So this way I'm going to get two columns in the output. The next one is aggregate, and I can get the average also of these two columns. So few of the examples I have given to you, maybe you can go ahead and try many more things while you practice. And if you face any issues or challenges, you can let me know. And if you have any questions in these codes, you can let me know. Okay, then let's see some functions on short side also. So sometimes we might want to do a short, we might want to our data frame to be shorted based on some column. So for that, you can do very simple syntaxes are there. Just apply this code and just say dot show, and it will get sorted based on the population. So the countries which have lowest population is going to be appeared first in the output. Come on. So if I just paste this data frame, you can see here's my population. The lowest population countries are going to be appeared first, and it's going to be applied in a increasing way. Okay, so actually this is all from IN for some example syntaxes of PySpark. There are many more. Okay, I'm not saying this is all that we have in PySpark. There are many more things, but these few things are the very much used or very frequently used in the real-time projects. So that's why I just give you some examples. You guys have to actually explore a bit more, and if you face any issues, any challenges, you have to let me know. And in the final project, we are going to see some more PySpark syntaxes different than these that we have seen till now. And yeah, in case of questions, let me know. No questions? Okay, then let me just go ahead and stop this notebook. Can I go ahead and stop this? Rama, Varsha, Nikhil.
No questions, Tejas.
Okay. I mean, you guys are getting it because I'm a bit confused or no question, no response. So you are getting it.
No question.
Okay. I hope you're getting it, Nikhil.
See, what I'm trying to do is like I will go through the recording again. That is what, because I missed somewhere, to be very frank. But I will try to catch up, Jalaj. Yeah.
I mean, what you missed, can you please come again?
No, I said I missed the flow. I missed a lot of basics, so that's okay, no problem. Anyway, recordings are there. We'll go through it.
Yeah, and in any case, if you find any challenges, please just ping me and I'll help you out.
Yeah, yeah. Please respond. That's what we are expecting.
Yeah, I will. I mean, I always respond. Just ping me on WhatsApp.
Okay, sure.
I mean, if you ping me on this laptop, this is Skype now. So this is actually my personal laptop. I just open in the evening times only. So if you ping me in this laptop, it will be a bit tough to catch up. But if you ping me on WhatsApp, chances are that I will be responding very quickly. I mean, if I'm busy with my office meeting, that is a separate thing. But otherwise, I'm going to respond.
Okay. No problem.
Okay, so I'm just going to stop this. And again, I'm reminding you, this is a chargeable thing. And I have tested this notebook with 2 workers today. And by default, this starts with a 5 number of workers. So please go ahead and set this number of workers to 2. Take this commands. I actually shared the codes, and there is these things are actually there. So this is actually eventually going to reduce the cost by half at least. And try with number of workers 1 also. If it works, I mean, then it's more than enough. We just have to test our code and try to keep your data sets small as possible. For the practice purpose, I am saying, because if you if you use the heavy data sets, then it's going to charge you more. Okay, then we have seen actually the visual job types. We created a very simple one. We haven't put up much time on the visual source and target and visual editor of the clue, because sometimes or most of the times in real times we do not use this. Then we have seen the Spark script editor, where we can write the complete PySpark code and execute that, and we could manage some settings there. Then we have seen the Jupyter notebook, where we can run and execute our code shell by shell. We can also go ahead and execute those in a line by line format if I place one line of code in one shell in that way. Okay, this is a better option for debugging and developing your code, but this is definitely not an option to schedule your jobs and codes to run in productions and like that, because this is quite expensive. Every second you keep this notebook open, whether you are working or not, it's going to charge you. Do not forget to shut down your notebook or stop your notebook once you are done. The last one that we have is Python shell script editor. This is the cheapest option that you have on the AWS Glue Studio. It just actually basically helps you write Python codes. No Spark functionality is available here. Okay, we have no choices of using complete Spark cluster, number of workers, all those things are not here. So if I just select this Python shell script editor, if I hit create here, I am going to get an empty code code page, you can say, and in the job details you will see a bit of difference. So if I just call this job name as a Python script editor, okay, and then okay, in the IAM role I will choose my AWS Glue access. If you see, the type here is not a Spark type. This type here is Python type. Python version I'm using 3.9. Okay, this is the latest version that we have till now. And with the introduction of Python 3.9, this you have the option of loading common analytic libraries. That means we can load pandas, numpy by default on Glue. Before this, these libraries were not present, and we had to include these things externally. And most usable is the SCFS. I'm going to tell you what is the difference here. Then if you see number of data processing units, we have 1 by 16. If you remember, in Glue, we were working with a 5 DPUs at least. And here we have the option of 1 by 16 and 1 DPU. That means either we can have maximum of 1 worker, or we can have 1 by 16 of a complete worker. This means two things. First thing, this is going to charge you a bit less, because DPU, see, Glue is charged like this. So if I just come here, it is important to understand the charging also. So let's say I have 10 DPU and my job runs for 1 hour. Then my bill is going to be 0.44 US dollar multiply by 10. That means I am going to pay $4.4 per hour. And this charges are same for your Glue jobs and Glue notebooks. So in Glue jobs, when you run this job, your job might get started and it will finish in 120 seconds or 2 minutes or 3 minutes like that. Then you are going to pay that amount. Okay, that means if it runs for 2 minutes, it's going to be, instead of multiplying by 10, it's going to be 2 minutes only. It's like this is 10 hours. Do not get confused. It is not minutes. And I'm going to pay a fractional of charges. If I run it multiple times, I'm going to pay more. But if you start your notebook and you use 10 DPUs and you use it for 10 hours, then this is the amount that you'll have to pay. And this 0.44 is amount for one DPU only. If you're using 10 DPU, then you have to pay, it's going to multiply by 10 again, because it's per DPU per hour charges we have to pay. So if I use it for 10 hours with 10 DPUs, and this is the standard rate, I am going to pay $44 per hour plus 18% of GST in India. So remember to shut down your notebooks. Now in Python shell, I am having only 1/16 capacity or a complete 1 capacity. That is only 2 options I have. So you understand that charges are less, but also the compute power is less. This is not supposed to be utilized for very heavy loads. Okay, so if you have data sets of MBs, it is going to process those data sets very easily. Okay, it's not going to take much time. But uh, if you need but if your data set is going to be more than around GBs, 5 GB, 10 GB data set, then obviously it is going to take more time. Okay, and one more thing that we need to understand, that here we also have no functionality of Spark. I cannot create Spark frame. Like whatever syntax I am teaching you from last 3 days, they are not going to work. Whatever we have learned in the starting of this course, the all Python syntaxes, the pandas data frame, the filtering of the pandas data frame, those all are going to work on this Python script editor. So this is a Python engine. Just remember this. This is a Python engine. Use cases wise, when you have small data set, you want to save some cost, you are okay to run your job for a little bit extra, add it and run your code in the Python script editor. When you have uh, quite a huge data sets and you have very complex logics, you want to explore the capacity of Spark, then you have to go ahead and use Spark shell editors. Okay, here I'm going to say save. My script has been saved now, and if I just come back to my script, so this is how actually I can create a code that reads the file from bucket. I have it's actually start from line by line. So I have first imported some of the libraries. I might not be using all of these things. Okay, but here if you see, I haven't created any Spark context, Glue context, or any of those libraries I have not utilized, because those are not supported here. Even if you try to import these things, it will not work. So basic simple libraries like input out for input output operations, OS for OS related operations, system library, pandas, CSV, Photo3. These are the few libraries that I have used here. Then I'm simply defining my bucket name and my file name I am defining here. So my file is stored inside sale data folder in the name of with the name of sale underscore report.csv. I call my function of reading the file. This function takes 2 arguments, or you can say 2 inputs in easy language. That is my bucket name and my object key it takes. Okay, then in this one I have also actually given you an example of exception handling. Okay, so I just say try, then I say expect. This means inside my try block, my code is going to try to execute this code. If there are any logical issues, this like if there are any syntax error, this code is not going to be get compiled. But if there are no syntax error and if there are any logical issues, my code is going to throw the exception. Okay, and that exception is going to be this match is. So it will be clearly indicating me from where my code has failed. So it helps you in the debugging part. And also if you wanted to, let this code still run. So I could have called one more function here, and that function could have, instead of raising exception, I could have continued my code also. So exception, sometimes if you fail the code logically and still you want to run the code, so those you can do with a try and accept exception blocks. And these try exceptions are like there in most of the programming languages, and it is a very common concept. And we follow this in real times, or you can say production codes to handle some exceptions. Some exceptions we might want to continue our code, and some exceptions we want to fail our code purposely. Okay, so this is the use cases of exceptions. Then if you see, like instead of providing a direct file name, I'm reading my object. I'm also saying pandas has no feature to pass file s3 from directly, but this is a old statement. Okay, from last I think it's from last December. That is what they have introduced the Python 3.9 on the AWS Glue, and that has provided you the SCFS library that helps you to read the files directly in your Python script editor on Glue. You don't need to go ahead and create the buffer of your file. So here what I'm doing basically, I am create my client first. We have seen in Lambda functions that we go ahead and create the client of the service where we want to interact. Okay, so here we do not have no option of using read CSV directly of the code that we were using earlier. This spark.read CSV is not there. The glue dynamic frames are not there. This is, again I'm repeating, a simple Python shell. All the Python programs can be run executed here, but all the capacity of Spark cannot be run here. So I'm simply creating my client of S3, reading the object from S3, and I'm saying get object. In get object, I'm passing my bucket name and my object key. This is going to create an object of this file and going to store that in a file obj variable. I'm calling this file object, and from that file object, so basically here an object is created for my file, and from that object I simply say I want to read the body of my object, and it gives me the file contained. Okay, I'm going to get the file contained, but my pandas data frame needs a file buffer. So that file buffer I'm going to create with the IO, and then dot bytes IO have to call to create the file buffer. Once I create my file buffer, it's going to, if you see, this is the last line of my code. I am going to print the file contained. Okay, and after that, actually, I'm also creating the file buffer. This read data I am passing inside read CSV method of my code. Obviously, if these 4 lines executes without any issues, this exception is not going to be occur. I am going to start writing my file. Okay, writing my file to pandas data frame, and here I am saying pd.read CSV. Instead of providing a file path, I am providing a file buffer, and some other options I'm providing. I have no index column, I have a separator, and I have no skipping no rows, and like that I am going to create my pandas data frame. If the code executes successfully, I am going to get the message that data was loaded into pandas successfully. Once my pandas data frame is created, all those options, all those codes that I have shown you in the first week of this course is going to work. It's going to be work flawlessly here. One more thing before you start asking me questions. This process, you can say it's a kind of a old process. Okay, the reading of the file has been changed Now you can simply go ahead and give the S3 location like we were giving it earlier. So if I just get that code for you. So, instead of doing all this, I could simply command this and I can say pd.readcsv. Okay. Instead of doing all this thing, I could command this and I can say pd.readcsv. Like, okay, I can directly call this readcsv method and I no need to pass read data buffer. If I no need to pass read data buffer, I no need to create this. I am actually telling you about this process because it might happen if you join some project now, and if they are using Python shell, then they might be coding it like this, because this functionality of reading directly like this using a location is only started from few months back. That's why I'm explaining you all this. So let me just get this code on Visual Studio Code. And if you have any questions about this, please let me know. Okay, so if you ask no question, I'm assuming that you have got what I was trying to say. Again, repeating, this is an absolute code. No need to do it right now. You can simply use Python 3.9 and simply just say read CSV. And all the other things, I have just given you an example that how the code should be written in the project, in the production or real time. So we follow the process of defining every task in a method or a function. We define functions argument, so that I have not done for this one, but I have done it for the save file. You should define the function arguments, like what are you taking as an argument, what is it's going to return. Okay, so all those things we should mention in the function definitions. If I just come back here and if I execute this code, for now I am just going to change the path here. So let's say I read this data frame here. And I call it df region. Then I'm going to say print df region. And just to let you know that we could read it, just to give an example, that we could read with this thing also, and we could read with the above code also. I'm just going to hit save, run. For this, I need to open my CloudWatch logs. And if you see that I was able to read it will come, just to give a second. Job is still running. It failed with some issues. Could could not read. Okay, I actually forgot to mention the S3FS import S3. Let me just check it. What is F is capital or not? Is this one? Save and run again. Okay, if I give it the file name, if it fails again, I will fix this and I will show it to you. Could not read data from S3 directory. Okay, I'll fix this. I might have deleted some uh could not read directory. So I am getting actually in this message. That means somewhere something is wrong here. Maybe let me check if I still have this bucket and if I still have this file codes. If I remove this, sale data is there, then sale report. Okay, file name is actually different here. Okay, yeah, file name is different. So I'm just going to try one last attempt. So actually my file name was wrong here. That's why it was not able to read this. If I execute this now, it should be good. Let's see what we get on the output side. So you can see this time I'm able to read my data. I was able to read my region file also, and this is the this is what I'm getting in my content path. So if you see, I'm also printing the content here. I'm printing this content. This is my content that you can see on my output logs, and then this is the output of this command print statement, and after that I have successfully able to convert the data frame from my content that we have on here. So this is how we can read and convert our CSV files into data frames. Okay. So let me know if you have any questions about this. I will say if you don't get it, ignore this code. Just use this code to read the file and start modifying or transforming your data. Any questions, any doubts? We all good?
No question from my side.
Okay, then I'm going to stop recording.